All right, milk check. 1, 2. The milk is plenty cold, ready to drink. We're going plant based today. We're gonna have some flax milk, unsweetened. It's good stuff. Try it. But anyway, mic check. Yep, things look good. So welcome to hopefully what is good choices. But if it happens to just be mass public embarrassment and humiliation, hey, that's fun too. So let's continue with automate your
That's hard.
network by John Cabo. Or there's a P, so Capobianco. I think it's how I don't know. But so we were in chapter 4, part 1. We were trying to make it go vroom in the lab. In the lab, I do have visual Visual Studio Code set up and ready to go. But on my on my just local, I don't know, like I've always found something like Visual Studio Code to just be distracting, and it kind of like gets in the way and like wants you to do things like in a certain way that sometimes like it's just like it's like you can't use the hotkeys you're used to anymore, and it's just like yeah, I found like sometimes even though it's meant to make things easier and better, it makes things more difficult. So what I like to do sometimes is just use multiple windows. There's I don't see the reason to always condense things down into one window. I don't think that's always better. So we can see we've got get up in here. We can see we've got some new notes. So now it is now that now so the other thing that's good about this is we can see like where it does make a lot of sense to use Git. Like for example, this isn't that great. We can't see what was changed in the side by side. We can see that in Visual Studio Code. So it is nice to have that. And some of the problems I was facing in Visual Studio Code might have been resolved when I deleted it, and once I reinstall it, it'll probably be good. So you know what? I think I'm just gonna do that now. Let's get Visual Studio Code running because it's kind of been a bit of a fight to get used to it. So I think I do kind of want to continue that fight. Because the goal of this is to um, get through this book, and this book recommends using this. Now, in the real world, you're trying to figuring out, honestly, like count on your fingers, use a paper and pencil, like just get things done, get things working. Working code is really what matters in the end. But for this book, let's try to use the tools that this book is that are a part of this book. But I hope this makes sense. Every moment I'm doing this is a moment I'm not either reading the book or actually making progress in my code. And there might be something like an escape philosophy where, like, every hour I spend on these tools is like an hour less it takes me to code later. Okay, but I don't know what the calculations are on that, and if the deadline is a week from now, that doesn't really matter much. Okay, so here's our new so we can see what we did is modified this file. So let's commit that. So we'll say added the modern ndlc to the notes file. Yeah, see how much better this makes it, and I have to stage the change before I do that. So click that, and then we'll do commit, and there we go. Now it's back there. Looks like we've got a few. Oh, we've got to reload the Pylance extension. I'm not sure what that is. But yeah, okay, everything seems to be working better. I guess there was just some setting or something that made it not so good. Okay, so I think this is where I left off. Let me make sure here. Nope, it'll be Ansible module is where I left off last. So let me see exactly what it was. It was Ansible module dash. And then iOS command, not iOS. Or, okay.
Some advantages to
We definitely did the gather information part. I remember that.
non-disruptive, non-intrusive, no chance of anything going wrong, simple and easy to get going. Basically, converting the commands normally to run on a device to a simple script, dry run process, start building a system.
Okay, so that looks good. So, yep, we're on the IS. Yep, so we finished the gather information. So now we're on an Ansible module, which is iOS facts. So I'm going to take a quick break and then we'll start the video. All right, welcome back. Let me knock off a little bit here. So Ansible module iOS underscore facts. Ansible has a built-in module, which is iOS underscore facts, that can be used to gather facts from the Cisco iOS devices on the network. Simple to use, the iOS underscore facts module is a great place to start. The basic information about the hardware configuration and interfaces is returned from iOS underscore facts. The default setting includes all available facts about a device. However, it is possible to limit the scope of what iOS underscore facts includes or excludes from the playbook. Examples of iOS underscore facts usage are included in Chapter 6. It should be noted that other similar fact gathering modules exist, such as NXOS underscore facts. So that must be for a different kind, for Cisco Nexus, for Cisco devices running the Nexus operating system instead of the iOS operating system. So a mix of limiting to specific subsets of facts, or any fact but specific subsets, can be used to adjust the scope. Some basic examples from the Ansible iOS underscore facts module documentation. So you can collect all facts from the device. So iOS facts, gather subset all. So these are just different options you can have for the gather subset. The other thing you could do is collect only the configuration and default facts by changing the gather subset to config. You can also make it so that you do not collect any hardware facts. So you can do that by using this special character here to say not hardware. So just like with anything else, you could do it for not config. And it looks like this is a special character. So for more information about iOS facts module, please visit here. And then for more on Cisco and Ansible, we would visit here. I'm not gonna, well, you know what, let's just open it in a new tab. That's kind of the spirit of this channel, is to dive in deeper, really get a foundational understanding of things. Oh my god. Alright. Ansible Galaxy, I've never heard of that. I'm starting to get triggered. I don't know. It's just like, this is all. It's just kind of frustrating because like, it's Python. Like, it's just. I feel like it's just really like overcomplicating a lot of this. And then the other thing is like, not only is it overcomplicating, just the fact that this is literally just programming something in Python, and you don't need like not only is it, so when you download this thing, you have code on your system that you're not going to use. When you have the skills to develop and to write code, and you write code, now you only have code that you're using. So it's like, I don't know. I feel like the expertise now, this because this is not a project from a single person. This is a whole team developing this over a long period of time. So it's like, yeah, it's conceited and it's arrogant to think you're just going to write your own Ansible and it's going to be better than anything Ansible can do. But I mean, at the same time, it's like, I don't know. Well, let's just leave it there and continue working through this. So the next section is Ansible module iOS underscore command. And I need a break. I'll be right back. All right, welcome back. Let's keep going. So the next is Ansible module dash iOS underscore command. Another way of gathering information from the network is using the simple and easy to use. And let me do a check 1 2 1 2. All right, looks okay. A simple and easy to use iOS underscore command module. This module can be used to gather output of iOS show commands. Become comfortable with iOS underscore command. Build on the ability to gather information from the network and use the module to change the network. Here are some ideas of show commands that can be performed using iOS underscore command module to gather network reconnaissance. Alright, so I'm going to read through these. Now, I'm not sure if there's like a specific walkthrough or anything for like a lab for a lab of some kind. I don't see one. He did say in chapter 6 there was going to be something kind of like that. So we're still on chapter 4, so I don't think we're quite there yet. I'm tempted to fool around in my lab a bit, but I'm just worried it will not be time effective. But right now I'm gonna read through these commands. So the first one is show CDP neighbors. That'll give you, and let's do these commands just because I can. It might be interesting. So we're gonna take a look at how these could be useful for network reconnaissance. We're just gonna do these commands and get a better sense for how they might be useful. So let's go to our Cisco core here and run all of these commands. So the first command is going to be show CDP neighbors. All right, so we've got to enable. See, and this is useful as well. We're presupposing a state of the network, and you can't always do that. So see how you had to enable it first. That's very possible sometimes. In fact, likely, and that's why. I mean, honestly, like once you get your network up and running, and you have those prerequisites, you have in-band access. It's fair to presuppose a few things like OSPF neighbors to be enabled. So. Or sorry, CDP neighbors to be enabled. So we got CDP neighbors, we got show spanning tree, we got show spanning tree block ports. Next one is show IP OSPF neighbors. And this is the other thing too, is it's depends on your operating system which command is valid. And this is where I say learn how to code, because if you're just using iOS command this and it fails, if you're a pure coder and you're bringing that to the network, it's like you're still thinking about how to apply your network to the code. You're no longer using a predetermined tool and wondering why it fails when it fails. So when you're developing this stuff, in my opinion, you want to always be on the command line, and you want to always put it into the context of what you're attempting to do. And just kind of mindlessly running a tool like Ansible is, in my opinion, right now, before having completed reading this book, kind of doomed. It's kind of a recipe for disaster, and I think it's possible to even walk away from having done that, thinking that Ansible just doesn't make sense to use. It's like, well, you know what, it just depends on how you're using it. All right, so next one is show version. Then we've got show inventory. All right, and then show. So this is a useful one. We've got the serial number, and as I mentioned, the serial number can be really valuable because if the host name's off or whatever, it's a unique identifier you can use to really be sure what device you're on, which is important. So then, especially like if you're on like virtualized software-defined devices, show interface brief, IP interface brief. That's a good one. Show ARP. Show MAC address table. Oops, and this is another one where it's really different depending on what your device you're on. Like this is a router, so like routers don't even really have MAC address tables unless they've got like some special feature. And here's another one, ether channel summary. Show eth. Yeah. Port. Or channel. See, it doesn't even have port channels. It depends on the device. These are just all commands that could be useful depending on your specific device and your specific circumstance. They might not be so useful. So VLANs is 2 as well. These are it looks like it does have VLANs. I'm kind of surprised by that. Okay, so here's the access lists. Don't have any defined. Show policy map. This is for like QoS or like whatever you need it for. And then show tech. Show tech is the big one that tech support will ask for if you're opening like a TAC case, it's called. So when it comes to your automation, show tech's probably a good one because you can really you just got everything. You've got a full show run. You're moving a lot of data across the network, but like, you know, when you're working with code, like you can scale up to handle a lot of data. So like show tech is probably a good one to know about. All right, so it might seem impossible. However, any or all the above commands can be performed on any or all the network devices on demand or at scheduled times using Ansible playbooks. Well, as we said, you know, there might be some difficulties with that, so definitely going to try it out on my lab, see if we can work through those difficulties or see if it's just easier than I think. If the output of the commands is kept in the master branch, when changed, TFS will show the change history for these output files. This makes it easier to detect state changes on the network. This could help keep track of topology changes or hint to potential problems or unreported outages. Manipulate the output of the commands and store them in the centralized repository for version and change control. More on the command iOS. The iOS _command module can be found here. One-time Ansible playbooks / tactical changes. The automated network reconnaissance has led to some discoveries on the network that need to be addressed, such as large-scale feature deployments, large-scale corrections, single one-time changes, and configuration management. So Ansible module / iOS _config. Building on the iOS _command module, a new Ansible module - iOS _config is used to perform changes on Cisco Catalyst devices running iOS. Think of the iOS _command module as a tool used in exec mode on a device that is able to perform standard show commands or copy run configuration startup configuration commands performed at the user exec level of iOS. In contrast, the iOS config module can perform privileged exec level commands used for device configuration. The iOS config module is used to execute commands that make changes on the network. More on the iOS config module can be found here. Oh, so yeah, it looks like it's for oh, so this was the iOS command. So this is like for show commands, but then they have another one for actual making changes, and that's iOS config. Chapter 7 provides examples and expands on iOS config utilization to automate tactical one-time plays. Perfect. Okay. So yeah, chapter 7 will dive into it more in the lab. I do want to go through my lab quick again. We see we got a data center, we've got a campus, and we've got a WAN that connects our data center to our campus. So I do have a lab to play around with. I use the AI to try to set this up. So we could do that now, or we could wait. I don't have much time. I have to actually stop making this video real soon. So let me get through. Let me get through this next section. Is the chapter almost done? No, there's still a lot left in the chapter. So let me. Oh, well, there's not that much. There's not that much. Well, now I'm in kind of a pickle. I guess I could pause it and come back and close out the chapter. Let me do that. So we're going to read about configuration management. We're going to spend another 5-10 minutes, pause it, and then tonight I'll finish out this chapter in this one video. Just leaving it paused for a long time is totally fine. All right, configuration management. Ultimately, the goal of network automation is to provide complete coverage of all network configurations and required changes to those configurations. One-time tactical playbooks are incredibly powerful. However, these playbooks are simply moving the execution of CLI commands from human input to an automation engine. While network reconnaissance and executing tactical commands can be performed at scale, full network configuration management has not yet been achieved because no source of truth exists, and that is important. Source of truth is important. The network is not yet intent-based, since there is no automated provisioning. The powerful dynamic templating engine has not been put into use. Automated documentation and configuration management involves the abstraction of data from network configurations. Data models are built around the relevant information a device contains. The actual configuration commands are then transformed into templates. Variables are substituted with information contained in the data models at runtime, making the templates dynamic. Standardized golden templates ensure configuration consistency derived from intent. Intent is derived at scale. Standardized golden templates ensure configuration consistency derived from intent is applied at scale. Expand on the utilization of the iOS _config module to automate network configuration management. For the most part, code will continue to be written as YAML files, but now Jinja 2 templating is introduced to hold the mix of programmatic logic and static commands to build new templates. This process can be done in any order, but here are the building blocks needed to automate network configuration management. Okay, so the first thing we need is to create variables in data dictionary. We need the group vars, we need the host vars. This will be in YAML file format. It will be an abstraction of data from device configuration in key pair values and also in lists. Then we need to create small templates that generate configurations, and we'll do that using a Jinja 2 file format. These will be dynamic templates. Any variables will be filled in dynamically. There'll be a mix of static text variables and programmatic logic. Variables replaced with information from group vars and host vars. For loops iterate over lists. Basic if, else, and end if comparative Boolean logic. All right, so then the next thing we'll do is create tasks. This again will be in YAML format. Or sorry, no, this will be, so creating the variables will be in YAML, and on the tasks, creating small templates, that will be in Jitra. So this is in YAML, just like the variable creation, YAML file format. We'll be using the Cisco iOS underscore command module. I'm not sure. So I've got a very much a multi-vendor environment in my lab. So I'm not sure how to work around that. You know what I might end up doing is just writing my own version of Ansible. I think that's very valuable. But we'll get into that later. Okay, and then we're going to call the templates and assemble the templates. So the next step is to create playbooks. So identify scope, which devices to execute tasks, call the tasks, and then execute using Ansible-playbook command and options. So here's the next section is data model structure. I am out of time, unfortunately. There's really not much left to this chapter, especially since I don't know. Yeah, there's just a few pages left. So I wish I could close it out now, but I am completely out of time. I don't think I can get through. Let's see if I can get through to this starting small section. So this is data model structure, like the investment and thought that went into the host.ini structure. A lot of upfront time and planning is required to build data model structures. Some basic formatting standards, variable naming conventions, and a variable dictionary hierarchy should be established and followed rigidly. Group vars. As part of the repository structure, there is a folder called group vars, which is an Ansible specific folder used to set up data models for the groups configured in the host.ini file. And maybe I can see that. I am pretty much out of time, but I'll just have this up anyways. Okay. Okay. Group variables are applied to all common hardware platforms or logical functions. If, for example, a common QoS policy is configured on all the distribution switches, abstract QoS policy into a model in the campus-distribution.yaml group vars file. So if you create a new policy, be sure to abstract the policy, the policy into that file. Let's do which on Ansible, and we see it there. So now let's move into user bin. So the thing is, Ansible is this is not for the files. Like, we won't get the group vars. I think what we could do is do cd just back and do find or like a sudo find name group vars. Okay, yeah, so it's a part of our repo. And we can see that just in here even. Oh, did I not have a poll? Am I in the wrong branch? What's going on here? Why don't I have all the files? Oh, that's why. So it looks like I updated my main branch by accident with all these files, and then I don't have like the fact that I'm working with one branch is like kind of like with more than one branch is kind of like messing me up here. Um, but so the group vars file is under the main branch. All right, so group variables are applied to all common hardware platforms or logical functions. If, for example, yep, we read that, campus distribution can be called as a group vars by creating a YAML file called campus-distribution.yaml inside the group underscore vars folder. This allows the data model to contain variables that apply to all devices listed in hosts.ini file subsections, creating a golden configuration by platform or logical function. It is recommended practice to prepend all variables created in group underscore vars with a common identifier such as platform, group, or global, and then underscore afterwards. For example, platform underscore defaults or group underscore VLANs. Using this naming convention when writing dynamic templates allows for the intent to become obvious to the operator. It also points to a file in the group underscore vars folder as the source of the data and variable. I'm going to say I'm out of time. I'm going to save it here and then come back. When I come back, go through there. I do need to figure out my problem here with my main branch not being up to date with my branch that I'm working in. So that was a mistake on my end. That's why you gotta like lock down your branches and like make it so that you can't really edit those branches unless done in a certain way. So you can see here I'm in the main branch, and that's why I see here and I see it different there. So definitely need to be working in the correct branches. That's really important. We can see what happens when something goes wrong there. So yep, that's going to be it for now. I'll come back. So I'm just going to pause it and be back and close this out later. All right, I'm here to finish this up. So we're going to finish up chapter 4, starting on page 84 here. The data belonging, and we'll do a mic check. Mic check 1 2 1 2. A little bit quiet, but maybe that's better. Alright, the data belonging in group underscore vars and host underscore vars should be considered carefully. There are advantages and disadvantages to either approach. I'm not sure what the two approaches are. I don't know what the two approaches are. I'm not sure which. Okay, so generally, group vars should contain as many platform or logical function standards as possible and can be used to reflect solid network design adhering to best practices. Sometimes using grouped vars does not make much sense, as the case of a hostname or management IP address, which naturally fits as host vars. So include host information inside group vars where it makes sense. For example, as a standard, all distribution layer switches should have port channel 1 configured as the uplink to the core. Port channels are usually distributed as a host variable, but in this case, port channel 1 will be listed under the campus distribution.yaml group variable. Some examples of group vars candidates. It looks like as a best case, there should be port channels going up to the core here. I'm not sure if I can do that in my lab. So I've got space on there, but I have to add more interfaces here to do that. Okay, so include host information inside the group vars where it makes sense. For example, as a standard, all distribution layer switches should have port channel 1 configured as the uplink to the core. I don't have that in my campus enterprise network. Port channels are usually included as a host variable, but in this case, port channel 1 will be listed under the campus distribution.yaml group variable. Some examples of group vars candidates: standard NTP IP helper addresses for DHCP, SNMP or syslog servers, access control lists at the distribution layer, QoS policies either by platform, logical function, or both, banners, AAA configurations such as Radius or TechX Plus servers, universal secret, standard interfaces, VSS configurations for core and distribution, standardized uplinks, domain name, native VLAN, multicast, NetFlow, performance type identifier, other features with common code across a platform. Alright, so host vars. Similar to group vars, there is a folder in the repository called host vars. In this folder, there is a YAML file per device. Dist1 YAML is the host vars file for that specific network host. Store information that is specific and unique to the device on the network in the host vars YAML files. Depending on the size of the fleet, it may take time to build complete coverage of the devices or configurations. Over time, it becomes a matter of cloning an existing host vars YAML file and replacing the data unique to the device. It is recommended to prepend host vars variables with hosts underscore for ease of readability and reference point as to where the variable is in the repository in a host underscore vars file. Some examples of host underscore vars variables include hostname, management SVI IP address, VLANs, VRFs, routing instances, switch virtual interfaces, also known as SVI. These would be for non-management purpose. Physical interfaces spanning true priorities, unique secrets or passwords, DHCP servers, switch stack configurations, and power stack configurations. So starting small, the approach taken to network configuration management may very well determine its success. Do not try to solve everything at once. Break the network down into small modular templates that can easily be read, understood, and updated by others. The templates should cover specific functions and features. These small templates can and will be assembled later at runtime, so do not be afraid to make very small, very specific templates as opposed to large one-size-fits-all templates. Use check mode extensively, refactor code, start making manual changes and corrections to the network. Try to achieve idempotency. Alright, so coverage by configuration. Prior to building templates, create and name empty files in the appropriate order the templated configurations are to be executed. It might not be possible to mirror exactly top to bottom configurations of a network device, but that is not the goal. The goal is to ensure all the configurations match and will execute in a functional order. The exact line-by-line configurations do not need to match sequentially. The number of templates created largely depends on the number of technologies and features deployed to the network. There are, however, some common configurations to every network. Here's an example library of small modular templates that can be used for a standard campus network. Use this structure to start a dynamic template library. The entire repository is available for cloning using Git. Locally to examine the logic in each template. Remember, if platform underscore or group underscore prepends a variable, it is stored in a group underscore vars YAML file and applies to a group of devices. If host underscore prepends the variable, it is stored in a host underscore vars YAML file. The templates are enumerated to control the serial order of operation in which they are processed. So here's the enumeration here. And then I don't see any underscore vars, anything like that, but let's read it through. So this 01 iOS global.j2, so J2, it's a Jinja 2 file. It contains device global configuration commands. It has static explicit text. It has logical operators, and here is a sample. So we've got service configuration, and we've got hostname configuration. And notice how we have dynamic variable here. You just plug it in there. So the next example, example 2, is for so the first example was for global configuration. The next one is to configure a DHCP server in Jinja. So devices that act as Jinja B servers, those are, that's something you can use, put in this file. So the next file is 3 iOS management source, standardized management traffic sources applied across enterprise. And here's a sample of that. We see a conditional statement in our Jinja 2. And then this is if it's a core. Then we have different configuration if it's not the core device. Yeah. So then the next file is to configure VSL, virtual switch link configurations for VSS devices applied at campus core and distribution layers. Kind of need to update my network. And then 5 iOS power stack .j2. So switch stack power configurations applied at campus access layer. And then 6 iOS archive so switch archive configurations applied across enterprise. And then iOS default gateway standardizes the default gateway at the access layer, requires IP address scheme with a per building per floor approach, requires host defaults.site variable in each host var's YAML data model. And here's a sample of that. We can see a conditional statement, and then it's got an or, so we're looking at the device type, and then depending on the if it's one of these device types, then we will configure a default gateway. So the reason we're checking the device type is because we only have these device types here, 3750 and 3850 in our core. Alright, so 08 iOS energy-wise. Energy-wise configurations applied across enterprise. Then SNMP related configurations per device applied across the enterprise. So they're not specific to a particular layer on the enterprise. Then we've got ACLs, access control lists by platform function. They're applied globally or uniquely. And then we have MLS and QoS. So QoS model for legacy multi-layer switching, MLS QoS. These are applied at the access layer on the 3750s. Alright, then we have 6K QoS model specific to the core or Catalyst 6000 platform. Alright, so then we have after that MQC QoS. So we have all kinds of different kinds of QoS that will apply. So MQC is modern modular QoS CLI, MQC model applied at both distribution layer on 4500 platform and access layer on Catalyst 3850 platform. Then we have iOS prefix list, standard prefix list commands used on core or distribution routers. Then we have route maps, so route maps commands applied at core or distribution layers. Then we have AAA RSA authentication, authorization, and auditing. This is RSA authentication applied across the enterprise. Then we have .1x, so .1x related configurations. This is port authentication, so not just anything can plug into the port, and it's applied at the access layer. And then this is .1x radius, 802.1x radius server configurations applied at the access layer. And then the next one is VRFs, virtual routing forwarding related configurations applied at the core and distribution layers. So here's an example of some pretty gnarly syntax here in the Jinja 2 file. You can see there's a point where you have enough of this in there, and it's like, well, Python is just as readable, if not more so. All right, then the next is the VFR list. VFR lists for easy virtual networking, also known as EVN, applied at the core and distribution layers. Then we have OSPF related configurations applied at the core and distribution layers. Then we have static routes, static route configurations applied at the core. Then we have VLANs, VLAN related configurations, which are a mix of global native VLANs and per host application across the enterprise. So here's a sample of that. We can see we've got the dynamic variables, nothing static in the file, and then we've got conditionals. This is another one where, Python might be as or more readable as this. I don't know, you decide. So the next one is VLAN interface, SBI related configurations applied on each host across enterprise. Then platform port channel interfaces, group_vars implied directly in template name, all port channels common to a platform. Then host channel interfaces, host vars implied directly in template name, all port channel configurations for an individual device. And then we've got loopback interfaces, all loopback interfaces applied to the core but can be used at distribution or access for management. Then platform interfaces, also known as which is DAD, dual active detection interfaces for VSS systems applied at the core and distribution layers. And then iOS host interfaces unused, standard interface configuration for shutdown/unused interfaces, security controls applied on all hosts, a port profile. After that is host interfaces for OP zone. So these are operational zone interfaces, standard access port configuration, a port profile. Then host interfaces for the security zone, interfaces used by security equipment, locked down access port, a port profile. Then host interfaces for WAP, configuration for an interface with a wireless access point connected. Some security measures applied along with power over Ethernet, and this has a port profile as well. Then we have host interfaces that are just custom ports. So custom access ports do not fit a standard port profile. Granular control with all interface options available as flags that can be enabled. Then we have multicast related configurations deployed at the core and distribution layers. And then the final one is NetFlow related configurations applied at the core, distribution, and access layers. The templates above, when combined with the information from data models, creates a complete network configuration for each device. Other features that arise can be cloned and modified versions of existing working proven logic. All right, so next section. And we almost got done. We got this page and then one more page. So the next section is coverage by platform. Once configurations and features are covered, confirm there are no syntax issues across different iOS platforms. These might be simple spacing differences. However, the templates need to match the running configuration or it will never be idempotent. Using check mode with verbosity and checking for idempotency between the coded solution and the running configurations gives a sense of when coverage can be achieved. A documentation.yaml Ansible playbook is developed in Chapter 9. This playbook generates offline copies of the compiled output per device used to validate syntax, spacing, and used as a source of truth about the intent-based network. Start evaluating how much of a platform configuration base is covered by the initial 35 templates. If there are gaps or outstanding configurations that remain on the platform and are not covered by a template, write additional templates to cover as much, if not all, of the device's configuration as possible. Next section, coverage by logical function. Like the platform review, ensure that the logical layers of the network have adequate coverage using group_vars, host_vars, and dynamic templates. Confirm that the core, distribution, access, WAN, data center, and DMZ are covered as logical functions when automating the network. So here we go. We're almost done. Hooray! What a journey. So, summary. Getting started can be a daunting undertaking. By breaking down the necessary steps into smaller, more manageable components, the path leading to network automation can be achievable with very few obstacles. Start with a thorough network readiness assessment where any gaps can be identified and addressed before beginning. A comprehensive, well-designed, hierarchical inventory file in the form of hosts.ini ensures coverage of the network. This offers scalability, modularity, and flexibility when executing playbooks. Starting with safe and simple information gathering and network reconnaissance, the organization can start automating network documentation without the possibility of disruption. After gaining confidence and skill, the organization can move into automating technical changes and task orchestration. Once the network has been standardized and brought into compliance with intent, the network configurations can be abstracted into data models and dynamic templates, moving towards full network configuration automation. Finally, a continuous integration and continuous delivery CI/CD pipeline is developed, achieving full network automation. Concrete examples of this evolutionary journey are found in part 2. And we are now done with part 1. So thanks for watching, and see you in the next video where I start part 2.